Hello, my name is Elizabeth Legerman, and I'm glad to present our presentation, the third Newton's law experiment. Objective part. The first, to calculate expected momentum by using velocity and momentum equation. To use a force sensor and weights in free fall to experimentally determine momentum. Be able to experimentally analyze data and measure expected data to prove Newton's third law. Theory. If object A exerts a force on object B also exerts an equal and opposite force on object A. Forces result from interactions. Other words, for every action force in nature, there's an equal and opposite reaction. Newton's third law can be provided during the experiment with sensor and string. By dropping the weight exerts a force on the motion sensor, which should in theory be close to the calculated expected value.
For this experiment, we need the following materials. Force sensor, 4 different types of weight, the massless string, Pascal 850 interface, a stand, and a computer with Pascal capstone software. First of all, we have to plug the 850 interface in the following location. And then we have to connect it with another cable with the computer that has the Pascal capstone software. The force sensor will be placed in one of the stands and is going to be tightened so it's not moving. A string is going to be tightened at the bottom of the force sensor, and then it's going to be plugged in the plug letter A and then turned on. We open the software and it will be ready to be used. You click hardware setup and then click the plug letter A and then force sensor. After that, we're going to start calibration. We click next and next again. Where it says calibrate the first point, we're going to type 0 for the standard value and then set current value. After that, we're going to place 500 grams on our force sensor. In number 5, the standard value will be 4.9. We set the current value again, and then we'll be finished. We go to the graph equation. Select the first one, and then the equation for today's lab is going to be force 2 equal parentheses force n plus 0.06. And then we're going to tighten the first weight at the very end of the string. And then we're going to measure the length from the top of the string until the end of the weight. The experiment will begin by dropping the weight.
Do not forget to press record. Once the recording is finished, click and drag the bubble across the first peak. Once you find the area, record the area in the Excel spreadsheet. In this experiment, we used 4 different weights: 0.02 kilograms, 0.1 kilograms, 0.2 kilograms, and 0.05 kilograms. Additionally, we measured the height of the string. We then used these values to plug in to the velocity equation. V is equal to square root 2 times the gravity times the height. the height needs to be converted from centimeters to meters. After finding the velocity value, we plug these numbers in to the momentum equation. P is equal to m times v. P is momentum, m is mass in kilograms, and v is velocity. After finding the momentum, we now have our expected value. We then calculate the absolute error by subtracting the expected value from the area value. We find the percent error by dividing absolute error by expected value times 100. The average for the values calculated from the data collection is found by using average. The values for each of the 4 different weights, and then we press enter to calculate the final value. The standard deviation is found by using E equals standard deviation of a sample size, and then highlighting the 4 area values for each corresponding weight. The average absolute error is found similarly to finding the average of the area. We use the average equation, highlight the absolute error values for each of the 4 corresponding weights, and press enter, and then record the values in the corresponding columns. The standard error is found by dividing the standard deviation by the square root of the amount of values that we use in each sample, so 4. We then use the average and the standard deviation to calculate the confidence interval minimums and the confidence interval maximums. To find the minimum, we can use the average minus the standard deviation, which gives us our minimum confidence interval value. To find the maximum confidence interval value, we use equals average plus the standard deviation, which gives us our confidence interval max. Repeat this step for the 4 corresponding weights.
Based on our data, we conclude that the confidence interval for 0.02 kilograms, it is 0.045 plus or minus 0.058. For the next one, we got for 0.1 kilograms is 0.2125 plus or minus 0.036. For the next one, 0.2 kilograms is 0.55 plus or minus 0.12. And for the last one, 0.05 kilograms is 0.1175 plus or minus 0.005. We can, with 95% confidence, conclude that the calculated data indicates that the force exerted on the motion sensor is equal and opposite to the force exerted by the weight. Sources of error in the experiment: improperly measuring the height of the string, improper use of the equations, and miscalibration of the force sensor, which all would result in unreliable data.
The conclusion was the expected value represents the expected momentum of the weight attached to the string. When the weight is dropped, the weight exerts a force on the force sensor that should theoretically be equal to the expected value. The experiment shows that the value for all of the sensor readings is very close to the expected value, indicating that there was an equal and opposite force exerted. These conclusions agree with Newton's third law.